work in an agricultural region and a 100% agricultural area makes me or exposed me to interact with agricultures and farmers every day. The more I interact, the more I get to know the problems they go through, the more I get to know the importance and the value of agriculture in our economy and our community. So, and especially after COVID pandemic and the Ukraine and Russian war, I got to know the importance of agriculture in the Moroccan economy. And today, agriculture represents about 15% of the Moroccan GDP, which is a big number. However, 35% of the fresh produce are lost every year because of spoilage. And that's what مناقشة is trying to solve. Juries, attenders, welcome to my capstone defense, where we're gonna explore مناقشة, the smart retail traceability and AI-based spoilage prediction system for Moroccan markets. As I mentioned, so before we're gonna go through the main problem, the solution, the system overview and architecture, dataset, model architecture and performance, backend and the front-end architecture, a demo, some limitations and future work. As I mentioned, 35% of losses are among the whole supply chain. Why? We have 25% only between retailers. Retailers combining both in markets and distribution centers. Apples are one of the highly affected crops. Due to the limited visibility on storage conditions, there is no affordable solutions, and retailers rely on visual guesswork. The thing that lead to financial losses and environmental waste. In order to solve this, they may look for chemicals. Chemicals, as you can see in the image, we inject our apples with formalin chemical, so it looks fresh, while it's not. It's harmful on our health and unsafe. That's why مناقشة combined both image analysis and environmental data to make smart detections, providing retailers with financial insights, helping them to track their inventory and supporting them with an AI assistant. And since Morocco is a multilingual country, مناقشة supports 3 languages, English, French, and Arabic. So, the main 4 components that are integrated are deep learning image classification, and since there is no available environmental data, we use environmental spoilage simulation. Then we have fast API backend with traceability and multilingual web interface plus a chatbot. Here, as you can see in this diagram, the user interacts with the web app, send requests through the fast API backend to access predictions, AI assistants, business calculators, and manage history. And all this data are saved in JSON file. In order to train my model, I used mainly fruit quality datasets. At the beginning, it was formed from 3 main classes, fresh, rotten, and images for apples with formalin chemical. However, when I was trying to train my model, the model couldn't learn because the fresh and the ones with formalin chemical are similar, and it cannot detect the difference between them. So, since our goal is to predict the spoilage and not detect the use of chemicals, I removed the 3rd class and kept only fresh and rotten classes that give us 2,500 images. I split my data into 70% for training, 15% for validation, and 15% for testing. I applied some pre-processing steps, such as augmented the resolution to 224 pixels, and also I applied RGB. I changed the format, and I used augmented on the training set, the main three factors that I use: rotation, flipping, and brightness. I tried three models. First, MobileNet V2, which gives an accuracy of 95%, then ResNet 50, which gave an accuracy of 97%, and then EfficientNet B0 that achieved an accuracy of 98.5%. For the test result, I used some precision that is showing 0.99, recall of 0.98, F1 score of 0.98, and area under rock of 0.99. And as you can see in the graph, the model keeps learning and the loss keeps going down. And also, this confusion matrix is showing, is validating our performance, showing that only 3 images were misclassified among the 375 images we had. Now that we are done with the image processing and the model, we need to integrate the main factor for the prediction, which is spoilage, which is environmental data. And since there is no available data, I relied on researches given by Food and Agriculture and World Health Organizations, along with post-harvest literature, and found that the main factors to evaluate risk are temperature, humidity, ethylene, storage duration, in addition to the oxygen and CO2 levels. Given 16% to the image model and 14% to the environmental model, now we have a very accurate and logical model to do the prediction. And once the model is ready, we can now upload an image, enter environmental data along with the actual price, and Manqida will give us a barcode to make each box unique. In addition to the risk of the level of the risk, the remaining days, the suggested discount, and recommended price. All these informations are saved in the JSON tracking. Now, the backend that use Fast API can do the prediction, answer requests from the chatbots, runs calculators, and load the history. The front end is built with React. It sends requests through the API to the backend to get answers, and all the information are saved in JSON. Right? This is a demo of Manqida. We log in using a username and a password. This is the dashboard showing all the options we have. And since I mentioned we have 3 languages, this is the French version, and this is the Arabic one. To do the prediction, we can either get started or go to scanner. Here we can drag or upload an image from our laptop. This is a box of apples from Marjan. Here we can enter environmental data and we change only temperature. Enter here the actual price and change the storage condition from room temperature to cold storage. And as you can see here, this is the freshness percentage and the risk, the remaining days, the discount to be applied, the recommended price, and the barcode to be printed. Now, this is the history, saving all our data. And the calculator. Here we can, for example, enter the daily waste, the value per kilogram, and it will give us the daily, monthly, and yearly savings. Here we can take the monthly savings to calculate the return on investment, the payback month, and the 5-year return. This is some information about the savings breakdown and by risk and the projection of each year saving. We can take a barcode, an ID for a box, and go to the assistant and ask any related question about our box rather than going through the history page every time. that our system cannot detect inside the fruits and spoilage inside the fruit. Also the chemicals used. And also, since we don't have access to real Moroccan retailers and distributors data, using like real environmental sensors and cameras. That's why, for the future work, I'm looking to integrate high-resolution IoT devices, cameras and sensors in real markets and distributor centers, building a mobile app and extending to multiple crops. To conclude, مناقشة is a working AI freshness predictor, a traceability and risk estimation system, a full backend and multilingual user interface, immediate economic value for retailers, and a solid foundation for a future production-grade solution. Thank you for your attention.
It's good to have full stack development experience, but in capstone I would expect something related to your specialization, because otherwise you won't excel in any of the areas. Okay? So if you opt for software, you can look for a model that was already pre-trained on similar data and you just integrate it. Okay? And you deal with all the challenges related to, like I mentioned earlier, machine learning engineering. Okay, it's a whole field by itself. Or you opt for AI, and then I would have expected that you try several models, and you can trust them, and you show empirically that efficient net B0 is the best. Okay, not trying one single model on your data. And again, it's nice to see the data science work, the hyperparameter tuning, the method for hyperparameter tuning.
Before leaving, I would like to thank Dr. Kamali, because at the beginning I wasn't so sure about your acceptance of my idea. As I know, you always
work back and forth
on languages. So I was like, if she accepted, it's a good sign to work on it and go on. If not, I should change to something else. And I would like to switch to Arabic. كنبغي نشكر صحابي كاملين، كنبغي نشكر بسمة على الدعم ديالها من أول نهار دخلت فيه الأخوين، كنبغي نشكر عائلتي كاملين على الحضور ديالهم، خوتي، وكنبغي نقول ماما وبابا شكرا لكم بزاف، شكرا على الدعم ديالكم، شكرا على ثقتكم فيا، كنشكركم بزاف وكنبغيكم بزاف.